8-2 wire with ground cannot safely carry up to 20 amp loads for nearly 1000 feet. The reason for this lies in voltage drop, which occurs when the voltage at the end of a long wire run is significantly lower than the voltage at the source. This reduction in voltage is due to the resistance of the wire, and it becomes more pronounced over longer distances and with higher current loads. Let's delve into the voltage drop calculations to understand why 8-2 wire is inadequate for this scenario. The fundamental principle we'll use is Ohm's law, which states that voltage drop equals current multiplied by resistance multiplied by length. In our case, the current is 20 amps. The resistance of 8-2 wire with ground is approximately 0.64 ohms per 1000 feet. The length of the wire run is 1000 feet, but since we are considering the total round-trip distance of the circuit, we effectively use 1000 feet in our calculations. Therefore, the voltage drop equals 20 amps multiplied by 0.64 ohms multiplied by 1000 feet, which equals 128 volts. A voltage drop of 128 volts is excessive. In a typical 120 volt system, this would mean that only a very low voltage, if any, reaches the campsite, rendering the power supply practically useless and potentially damaging to any equipment connected to it. To put this into perspective, most electrical appliances are designed to operate within a specific voltage range, typically plus or minus 5% to 10% of the nominal voltage. A significant voltage drop can cause appliances to function inefficiently, overheat, or even fail prematurely. Moreover, excessive voltage drop can lead to safety hazards, such as overheating of the wire, which can increase the risk of electrical fires. Now, let's consider a more suitable wire gauge for this application. For a 1000 foot run with a 20 amp load, a minimum of 6-2 wire with ground is recommended. The reason for this recommendation is that 6-2 wire has a lower resistance per unit length compared to 8-2 wire, which translates to a smaller voltage drop. Specifically, 6-2 wire has a resistance of approximately 0.37 ohms per 1000 feet. Using this value in our voltage drop calculation, we get voltage drop equals 20 amps multiplied by 0.37 ohms multiplied by 1000 feet, which equals 74 volts. A voltage drop of 74 volts is still significant. While this is a better improvement compared to the 8-2 wire, it's important to evaluate this value in the context of the supply voltage and acceptable voltage drop limits. To minimize voltage drop even further, one could consider using an even larger wire gauge, such as 4-2 or even 2-2, depending on the specific requirements and local electrical codes. These larger wire gauges have even lower resistance values, resulting in smaller voltage drops. It is important to consult with a qualified electrician to determine the most appropriate wire gauge for this specific application, taking into account factors such as the actual load, the length of the run, and local electrical codes. Undersized wire can lead to several adverse consequences. Firstly, it can cause overheating of the wire due to the increased current density. This overheating can damage the wire insulation, leading to short circuits, ground faults, and electrical fires. Secondly, it can reduce the efficiency of electrical appliances and equipment. When the voltage is too low, appliances may draw more current to compensate, which can lead to increased energy consumption and premature failure. Thirdly, it can create safety hazards for individuals who may come into contact with the electrical system. Overheated wires can cause burns, and short circuits can create shock hazards. Therefore, it is crucial to use the appropriate wire gauge for the load and distance requirements to ensure safety and efficiency. When selecting a wire gauge for a particular application, several factors must be considered. Firstly, the load requirements, which include the current draw of all the appliances and equipment that will be connected to the circuit. This information can be found on the nameplates of the appliances or in their user manuals. Secondly, the distance of the wire run, which is the total length of the wire from the power source to the load and back. This distance should be measured accurately to ensure that the voltage drop calculations are correct. Thirdly, the acceptable voltage drop, which is the maximum amount of voltage drop that can be tolerated without affecting the performance of the appliances or creating safety hazards. This value is typically specified in electrical codes and standards. Fourthly, the type of wire insulation, which can affect the ampacity of the wire. Ampacity is the maximum amount of current that a wire can safely carry without overheating. Different types of insulation have different ampacity ratings, so it is important to select the appropriate insulation for the application. Fifthly, the environmental conditions, such as temperature and humidity, which can affect the ampacity of the wire. High temperatures can reduce the ampacity of the wire, while high humidity can increase the risk of corrosion. Therefore, it is important to select a wire that is suitable for the environmental conditions in which it will be used. Firstly, determine the total load requirements of the circuit. This involves adding up the current draw of all the appliances and equipment that will be connected to the circuit. Secondly, measure the distance of the wire run accurately. This is the total length of the wire from the power source to the load and back. Thirdly, determine the acceptable voltage drop. This value is typically specified in electrical codes and standards. Fourthly, consult a wire gauge chart to determine the appropriate wire gauge for the load, distance, and voltage drop requirements. Wire gauge charts are available in electrical codes and standards, as well as online. Fifthly, select a wire with the appropriate insulation type and the ampacity rating for the application and environmental conditions. Sixthly, install the wire according to the manufacturer's instructions and local electrical codes. This includes properly terminating the wire at the electrical panel and at the outlets or appliances. Seventhly, test the circuit to ensure that it is functioning properly and that the voltage drop is within acceptable limits. This can be done using a multimeter or a voltage drop tester. In addition to using the appropriate wire gauge, there are other measures that can be taken to minimize voltage drop in long wire runs. Firstly, increasing the supply voltage can reduce the current required to deliver the same amount of power. This can be achieved by using a step-up transformer at the power source. Secondly, using multiple parallel conductors can reduce the resistance of the wire run. This involves running 2 or more wires in parallel to carry the same load. Thirdly, using a dedicated circuit for high-power appliances can prevent voltage drop from affecting other appliances on the same circuit. This involves running a separate wire from the electrical panel to the high-power appliance. Fourthly, using a voltage regulator can maintain a constant voltage at the load, regardless of the voltage drop in the wire run. This involves installing a voltage regulator at the load to compensate for the voltage drop. When working with electrical wiring, it is essential to follow safety precautions to prevent electrical shocks, burns, and fires. Firstly, always turn off the power to the circuit before working on any electrical wiring. This can be done by switching off the circuit breaker at the electrical panel. Secondly, use insulated tools to prevent electrical shocks. Insulated tools have a rubber coating that protects you from electric current. Thirdly, wear safety glasses to protect your eyes from sparks and debris. Sparks can occur when working with electrical wiring, and debris can be dislodged from the wires or surrounding materials. Fourthly, follow all local electrical codes and regulations. Electrical codes are designed to ensure the safety of electrical installations and to prevent electrical hazards. Fifthly, if you are not comfortable working with electrical wiring, hire a qualified electrician. The electricians have the training and experience to safely and correctly install and repair electrical wiring. In summary, using the appropriate wire gauge is crucial for long-distance power runs to ensure safety and efficiency. Voltage drop can be a significant issue in long wire runs, and it is essential to calculate the voltage drop to determine the appropriate wire gauge. Undersized wire can lead to overheating, electrical fires, and reduced efficiency. Therefore, it is crucial to consult with a qualified electrician to determine the most appropriate wire gauge for the specific application, taking into account factors such as the load, distance, acceptable voltage drop, wire insulation, and environmental conditions.